There we go.
All right, so I guess I better make a start then, given that we're coming up to time. So welcome everybody. So my name is Rene and I'm the training coordinator and one of the trainers with FHIR, also the host of DevDays, as you know. And for today, we're going to look at a session that has advanced search as a topic. And that's because we noticed that a lot of people are actually using search, the URL-based search options. But then you find that they still ask a lot of questions when it comes to the more advanced features of that search option. So yeah, the basic stuff like using querying for a patient and then using some search parameters like patient name and identifier, that's kind of okay. But if it gets a bit more hairy than that, like parameter chaining and using includes, using the iterate stuff, then you find that people sort of go like, I don't know, yeah, it's all in the documentation, but I haven't used it yet. So this session sort of assumes that you've played around with the basic search options. And we're going to very briefly in one slide reiterate one of the basic stuff. And then we're going to continue by looking at some of the more advanced features. Right, so let's do a quick recap of the basic search features. And just in one line, so we have the parameters for a focal resource, right? So if patient is the focal resource, then for that focal resource in our search, we can then use the predefined search parameters like name and language. And here we see name equals Jones and language should be either English or DK for Danish. So comma is used for or. Well, if all is well, you've already seen this and you know how that works. There are modifiers and comparators in our search, so you can modify the behavior of a standard parameter. I want the name to be not a fuzzy search, which is a search by default, but I want name to be exactly Jones. Or I want the birthday to be anything that starts after 2000, the year 2000. That's a comparator, right? But again, if all is well, you know how that works. Then we have forward parameter chaining, and that's an option that most people still find relatively intuitive, whereby we're actually searching for one thing, but then using a value, a parameter or a data element on another resource, basically, as a condition. So in this case, give me all conditions for patients that have the name Jones. And this only works, this dotted notation in the parameter chaining, because the condition resource, here in this diagram, shows you that there is a search parameter of type reference, and that search parameter is called patient, and that sort of mimics the reference that exists from condition to patient B, in this case, our example patient, Adam Everyman. There's also reverse parameter chaining going against the direction of the reference. Okay, give me all patients where the condition meets some kind of search criteria. But then we're going against the direction of the reference, and then you use the has parameter syntax. Give me all patients that have a condition that has a reference to that patient, and where the code on that condition is ear pain. Okay, so give me all patients that have a condition which is ear pain. Now, again, I'm assuming all of that to be familiar. So let's now look at include and ref include, iterate, wildcard searches, compartment-based searches, bulk data exchanges, which includes querying, and some more complex options if you need stuff that's even beyond that. Now, this is even a selection of the options, but it's kind of between or above the functionality that you've probably discovered on your own, the basic stuff. But there is some complex stuff out there that nobody really uses or that most servers choose not to implement. So in that sense, we're not focusing upon that in this particular case. Note to Nikolai, there are some people in the waiting room, so you may wish to let them in. Anyway, let's focus on include and ref include here. So, as always, I will recommend, and you will see this at the summary at the end, that you first, when you have some sort of search that you want to have satisfied, try to look at, well, what reference parameters do I actually have between the resource types in question? So in this case, if my search is going to be query for condition resources related to ear pain and include all of the reference patients that have that ear pain in my response bundle, then obviously this search is about two different resource types. It's about conditions and it's about patient resources. And then you start scratching your head and you're going like, okay, so is there a reference from condition to patient? Or is there perhaps a reference from patient to condition? And if you look at the diagram, you see that we've looked at both of the source definition pages, and we've seen that the parameter in this case goes from condition to the patient. Okay, so once we know that that reference exists, that allows us to construct our search. And in this case, that's give me all conditions with code such and such, which is ear pain from SNOMED, and underscore include condition colon patient. So why does this work? Well, get condition that has a certain code, that's part of the base search functionality, and underscore include, this is following the search parameter, which is condition outbound reference to the patient. Hence, the patient resource, which is the thing that's referenced by that patient search parameter, shown in green, is actually going to be included in the response. The alternative is basically to start with the other resource, but that means having to go against the direction of the reference. And that's counterintuitive, so most people actually don't like that. But it will work just fine out of the box, because you could do a get, give me all patient resources with where the name is Adam, and reverse include, because we're going against the direction of the reference, our starting point is the patient, and we're going against the direction of this reference, which means we use a reverse include, give me all patients with name Adam, and reverse include all conditions that have a link. This is the name of the search parameter again, that's defined for condition. So in this case, give me also in my response bundle all conditions that reference that particular patient with name Adam, according to our search criteria. So the first thing to do when you tackle some sort of search is always, either in a mental model or on a scrap of paper, create a model of what are the resource types involved and what reference search parameters do I have going from one to the other, etc. And in this presentation, you will see me actually use that approach for each and every search that I'm going to define. So in this case, example number 2 is an example again based on the inclusion of non-focal resources in my response bundle. Query and counter resources for Adam and include the reference patient. So the patient has to be in the response bundle, and include the referenced practitioner. Okay, so what do we have here? And you construct this graph again, shown here at the bottom of the slide, because we have condition, we have the patient resource, we have an encounter resource, and we have a practitioner resource. Okay, and then it says query encounter resources. Okay, for patient Adam, well, that's basic search mechanism. We've seen that before. Give me all encounters. Encounters are the focal resource. Where patient.name, this is forward parameter chaining. You should know about that. Give me all encounters for patient Adam. Okay, and include, but then we have to start with encounter. So include, how do I get from encounter to patient? Well, in our little diagram, we see that encounter has a predefined search parameter called patient that gets me to patient. Okay. So if I use include encounter colon patient, that will effectively result in the patient resource being included in the response bundle. And then in blue, include encounter practitioner, because again, for the encounter, we have a predefined search parameter for encounters, and that's called practitioner, and that gets me to the practitioner, so to speak. Hence, that include will work as well. Now, sometimes it's not sufficient to just do an include. You may need to iterate. And iterate is a feature that can be very useful when you do inclusions. Because the thing is that normally when you do an include or a reverse include, then you're only including things that have a direct relationship or a direct reverse relationship with the focal resource. But sometimes you may wish to include stuff that's not related to the focal resource, but you may wish to include stuff that's related to stuff that you have included earlier on. So you're sort of building levels of inclusion. Hence this level stuff. That's why we have a special modifier called iterate to basically instruct the server that I'm not just interested in the stuff that's directly related to my focal resource. I'm also interested in stuff that's in turn related to the stuff that I just included. A couple of examples coming up. So imagine that you have a resource tree like the one that you see at the bottom of this slide. So we have an observation which has member relationships, and that's also the name of the search parameter, with other observations, which in turn may has members other observations, which may have has member other observations. Now, then I want to search for this observation, a specific observation, let's say this one. That's the focal point, let's say, of my search. But I want to include this whole subtree. And normally, if you were to do a regular include, then it would only return effectively these three resources.
Y luego también mirando la especificación, la búsqueda que fue identificado si no está tipado, identificado es un código sistema.
Sorry, Rene, I turned him off.
All right, so we have the normal search shown here in green, as I said, would only give you the focal resource plus one layer of included resources that have a direct relationship to the focal resource. But here I want to include absolutely everything, so the whole subtree. And how do you do that? Well, on the include, you then modify the standard behavior of the include parameter, and you indicate that I want this to be applied iteratively. So first of all, the green, these three things are going to be included, but then the same included statement is executed iteratively. So we get the next level of iteration and the next level of iteration, and all of these resources will now be included in my response bundle. This could also apply to reverse iteration, so going against the direction. But again, the difference being that it's not just one level of direct correspondence between two resources, but again, it's about stuff that we included earlier on. So give me all patient resources. Okay, that's certainly give me all patient resources here with name Adam. Reverse include all the encounters that refer to this patient. Okay, and include all practitioners referred to by those encounters. So in this case, we have the patient. We reverse include, and that's what we have seen before, all encounters that reference our patient with name Adam. And then we include, okay, encounter practitioners. Oh, wait a second. But the focus of this include, which is encounter, that's not the same resource type as we have here. Okay, because it's in the second red step, there we are including the encounter. So we went from focal to a layer that had encounters. And now for those encounters, we want to get hold of the practitioners. So that's the next level up, really. So which is why we have to specify iterate, because I want that particular part of the search to apply to whatever I have inclusive of includes. And then apply, I want to have all practitioners related to that. Another example. Give me all patients with name Adam and include the patient links, because patient resources may have a link to other patient resources, for example, if they have been merged, and include all organizations that are managing those patient resources. Well, this example would result in this. The focal resource, Adam Everyman, including of linked other patients, and the organization for Adam Everyman. But it would not include these organizations that are related to these linked patients. Remember, those are now referencing stuff that's in the included resources, which is the other linked patients. So in order to ensure that those organizations are included as well, I have to use this iterate again. Apply basically that search part to the result of all the previous stuff that I have, all previous includes, so to speak. Another example. So here we have a patient and all of their observations. So I have a patient that has an observation, but I also have linked patients, and those also have observations. Now, if I don't use iterate, then it returns the stuff that you see in blue. Okay, so again, by specifying iterate, I'm going to make it clear to the server that I want that particular search part and this ref include to be used iteratively to include all of the observations on the patient and on all patients that are linked to my key patient, Adam Everyman. Okay, so quite a few examples, but by now I hope you have seen the basic principle behind this. Now, actually, there were some few things around iterate. This is actually implemented by most servers. But some of them, like the public Vonk server that most people use for testing now and then, it's actually set to 1. So this iteration level is limited to 1, but it's configurable. And if you look at Happy, then Happy chooses to cheat a bit. So if they find out that the focal resource type is A, patient or whatever it is, and then somebody uses a include B some reference, then it's clear from the context that what you actually want probably is to iterate, because otherwise nothing would happen. So Happy cheats a bit and then basically does an auto iterate. I'm not entirely sure that's without danger, but it just means that, yes, be careful, because different servers may have a different iteration level that they apply when you actually use this modifier. Then we also have wildcard searches. So instead of doing a thing like this, give me all encounters and include the patient and include the practitioner and include the encounter and include the appointment and include the diagnosis, etc., 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 you can simply use a wildcard. So you basically use an include encounter : star. So whatever search parameters we have for encounter that reference some other resource types, I want to include them all in my response bundle. And obviously this also works for reverse include. Now this is a potentially very powerful mechanism, but also quite a burden on the server. Not at this level of complexity that we're seeing in this example, but certainly if we were to combine this with iterate, then it's going to get a bit hairy. So examples include observation : star. So if you go to the documentation and look at observation, you will find that observation has quite a few search parameters of type reference. For example, has, member, performer, patient, etc. So by this, using this include observation : star, I'm going to include, well, all those things that are referenced by observation in my response bundle. I can also do that with a reverse include. Okay, reverse include, and then use it for iterate, and then go like, I want to have encounters. So all outbound stuff by an encounter. Okay. Patients, practitioners, etc., etc. So you have to be careful, especially if you do iterate, because an encounter may reference some other encounter, which means it's also going to expand all the references that that other encounter has. So very quickly, this will balloon basically, and you will return the entire electronic healthcare record if you're not careful. Right? So that's really can be a problem. So a heavy burden on the server, especially if you combine it with iterate. And that's why we have the second bullet here that none of the public servers that we tend to use for testing actually supports this. So apparently the burden on the server was found too high, or not enough of people were actually asking for it. Another nice feature is the compartment-based search. You can do some stuff with compartment-based search that's not really that easy to do. It's possible, but not that easy to do using some of the search stuff we've seen before. So first of all, you may not have come across compartments in FHIR, and compartments in FHIR really serve, well, mainly serve a purpose of access control. It's kind of a grouping of, a logical grouping of a set of resources. And here I gave the example of the patient compartment. So the patient compartment contains everything that's directly associated or related with the patient, and a few other resources that are in turn related to the stuff that's related to the patient. So let's say it's the clinical resources, the electronic healthcare record, the stuff that's pretty closely related to a particular patient resource. There are also other compartments, encounter, practitioner, device, and a few others. But we're going to focus in our examples on this patient compartment because it's the most intuitive one. So if you do a thing like this, give me, and this looks like a normal search, like give me or a normal get patient 123, because for compartment-based searches, you have to identify what patient you're actually, what patient compartment you're referring to. So I'm talking about patient 123 / condition. You go like, what? That's a bit of a strange syntax, right? Well, this means that give me for the patient compartment / 123, which is effectively the patient resource itself, right? Give me all condition resources that are in that patient's compartment. So it is a bit of a search. The second one is actually a bit more useful because the first one could be done using a normal search that we have seen before, but the second one could not. Let's look at this one here in the red circle. If this is my patient compartment, so the patient has conditions and observations and some other thing, then yes, this can be easily done because there is a reference there. So I can just use my normal search with parameter chaining and get hold of the patient and the conditions, for example. But let's say I have some resource here and I have a device, but the device does not have a direct reference to the patient. It is in some indirect fashion via some other resource that I may not actually know about. But using this syntax, compartment-based search, I can then say, well, any resources in the patient 123 compartment of type device, and then device has a search parameter to indicate the type of device, for example, a blood glucose device or something. So give me all devices, and I don't really care how they are related via or whatever to the patient. Just give me all devices of that particular kind that are in the patient compartment. So this is something that's not that easy to do using the regular search stuff you've seen before. Another example, we have a FHIR resource called communication. That's a bit like an equivalent of an email or a chat message, if you look at that in detail. So let's say I want to find all communication resources, regardless of whether the patient is a subject of the conversation, the sender of the chat message or whatever, or the recipient of that communication. So get /patient /123 communication just gets me everything, regardless of how that patient is involved. Okay. Now, in this case, the second example, I'm going to use the practitioner compartment. So for a particular practitioner /456, right, that particular practitioner resource and that particular practitioner compartment, give me all communication resources where the patient ID or the logical ID of the subject is 123. Okay, and I don't care whether I, as a practitioner, I'm the sender or the receiver of the message or somebody else. I don't care. I just want to get hold of all communications that I've had related to a certain patient. And again, this is possible using regular search, but this is more convenient. Now, when you talk about search, then pretty quickly you get into discussions around, well, if the scope of my data grows and grows and grows, and I use iterate, and I basically want to return the entire electronic healthcare record, you get into sort of bulk data discussions. What's the best way, really, to return bulk stuff? Well, for an individual patient, you could obviously use the $everything operation. And the $everything operation returns, well, as the name says, everything. Although there is a parameter to scope it down again if you want less than everything. You can use compartment-based search, and if you support, or if the server supports wildcards, and remember, not all of them do, but if the server supports wildcards, then getting everything in a particular compartment is effectively the same, mostly the same as $everything. You can have sent actually a bundle that contains multiple search URLs. Okay, that can then be sent to a server, and the server could execute them in parallel if it has such optimization features, and then return a bundle of bundles, a bundle that contains multiple response bundles back to you. And that bundle of bundles that's returned to you, that could effectively be the scope of the entire electronic healthcare record. Or if you want to do this for loads of patients and not just for one single patient, then there's a separate implementation guide for bulk data access, for the bulk data exchange of heaps of FHIR resources between systems. Now, what if you need something that's not covered by the stuff that we've seen, for example, in this presentation? I have something that I want to have implemented, but it's much more complex than what you're offering here in the search URL. Please note that, by the way, this thing is called search. So the original intent of that, when they developed the search option, was to basically deal with, well, search some stuff, put it on the screen, and then that's about it. But over the years, lots of new functionality has been added because people came up with lots of different use cases. But at some point in time, you have to go like the 80% rule in FHIR, like, yeah, this is complexity enough. So we're going to give you some other options, basically, to deal with more complex search stuff. And certainly this is one of the primary candidates. It's still based on the URL-based search mechanism, but it's a stored query type of thing. It's a named query. So you basically use _query, you identify the name of the query, and then you supply your list of parameters. And this effectively executes a search operation. And the result of that will be a bundle. So it still looks and feels like a search, but you're hiding some of the logic on the server side. But this can be very attractive, effectively, if you want to have some complex logic between various parameters. That's not that easy to express using the standard search. There's also _filter, and _filter uses a SQL-like, it's not SQL, but an SQL-like query expression language, OData-based, for those of you who are in the know. And that makes certain queries a bit more easier to express. For example, if you need OR type logic between parameters, and not between parameter values, but between parameters, then filter may be something for you. But this is not implemented in all FHIR servers, and that's why most people first go for the standard search options, and filter is a sort of a nice extra that some servers offer. But it could also be GraphQL, which is an entirely different approach, because that returns, well, random JSON structures. It doesn't actually return a bundle of resources anymore. But yes, it does provide you with a more powerful way of accessing data. There are also approaches to do SQL on FHIR. So you have a FHIR server backend, and you try to establish an SQL layer on top of that. And that may be a front end, or it may be native support. There are different ways of getting there. So to summarize, if you look at this advanced search presentation, then what I recommend you to do is that if you are trying to basically find or define the search URL for some problem that you have, then the first thing to do is to identify what are the resource types that are involved here, and what are the search parameter names of type reference, right, mostly. Do I use modifiers, comparators? And establish this sort of graph that I've used in various slides, whether on a piece of paper or informally in your head, if it's not too complex. But that sort of influences what focal resource type you choose. Sometimes when the question is, give me all patients that have such and such, it may actually be easier to create a search URL based on one of the other clinical resources and not as patient as the focal resource. So again, sometimes that's not entirely intuitive. So by creating this sort of graph, it may be that, this one has a lot of inbound and outbound references, and I'm actually not using a search parameter on patient. Well, if I'm not using a search parameter on patient, I may as well include it and basically use some other resource type as the focus. So sometimes you have to start somewhere that may not be entirely intuitive. And then the fourth recommendation, well, if the response bundle should be larger in scope than a simple include, then you have to use the iterate modifier. And we have seen the wildcard reference parameters, the star, but as of yet not supported by quite a few. The compartment-based search, by the way, which was listed here, is actually supported by most servers. So to go back to the learning goals, which were presented at the beginning. So the question is, do you now feel able to apply at least what you've seen here? It's not the full power, but hey, it's good enough, of URL-based search options. And the only thing that is listed under 2 that we didn't talk about were actually nested has reverse parameter chaining, right? Which is a very tricky subject. But this is actually not used in production that often. So that's why we decided to skip it and focus on some of the other issues. Now, I can fully imagine that you may wish to play around with this because this is a pretty tricky subject. And that's why on the, actually as part of the questions, the first question on the list is actually an announcement where you could find this file. This is the file that contains a series of exercises inclusive of answers. So you can play around with this stuff. Okay, so link can be found in the questions list. Now, feel free to always drop me a question if you want to. That's kind of the aftercare, you can say, when presenting a session like this. And with that, I think we can move over to our questions, if there are any.
Thank you, Rene. There are a few questions. The first question is, what's the difference of search parameter name attribute and the code attribute? I've tried to answer this question. I don't know if you can answer, because in search parameter definition structure, we have a code attribute and the name attribute. And people don't understand which is really used by the search engine.
Sounds like to me that these would be 2 different search parameters, and they're actually searching for quite different things. But obviously on a patient, we actually don't have a code search parameter. So
yeah, this is not the type of the search. This is attribute element in a structure definition of the search parameter. So they look similar, they have similar names. And as I see from documentation, probably the code is used when you search through parameters by posting parameters resource. And the name is used when you use it in query string.
Could very well be. I'm not the expert when it comes to structure definition. I just look at the behavior of the servers and work with that. So sorry about that. You can refer this question, obviously, to one of my knowledgeable FHIR colleagues, but I'm not the profiling type of guy, so I won't be able to answer any questions that go deeply into profiling.
Yeah, I forwarded to the FHIR chat because I think the guys who invented these 2 attributes should answer these questions, probably the Graham Grief or somebody else.
Excellent. Next question, I would say.
Yeah. Another question: What if FHIR search is not enough for me? Because we see the lack of like a logic, so I could not combine and or not only maybe in a filter, but nobody supports the filter parameter.
Well, those are actually were responded probably later on when they have not seen this slide yet. So the slide that I'm currently sharing shows you the alternative and more powerful options.
Okay, so we don't have questions in QA. Probably guys can unmute themselves and ask.
Well, I actually see some in the question list. It's actually quite a few questions. You may have to refresh, Nikolai.
Oh, maybe it's not refreshed. I don't know. Yeah.
Can you limit the iteration depth? Well, not as a client, right? As a client, you can only specify, I want to have it all, or I want to have one level of iteration, which is if you don't use the iterate modifier. It's up to the server to decide what level of iteration they're going to use. So in that sense, as a client, you have no control over that. But certainly on Happy and on Vonk and probably all the other servers, you can configure this to minimize maybe the server load if you wish to do so.
Yeah, in 8box, for example, you can explicitly control the number of iterations.
Which in time, that makes sense.
Yeah, we extended the iterate syntax with additional stuff. Okay, so let me read. So there are some questions about SQL on FHIR and how it's related to the FHIR search. Do you have any opinion about SQL on FHIR?
Well, SQL on FHIR is, well, there are security issues, but you have that in any facading or distributed type of environment. So I'm not going to discuss that here. That would be more appropriate in a security discussion. So yes, so I'm not going to touch on security stuff here.
Yeah, because second question about security, the question how to control which resources are returned to the user if it's not allowed to see something.
Well, the answer to that would obviously be an access control engine, which would control whether the search URL satisfies the various requirements, and if so, execute it, and then again apply filtering to the result set. Because the result set may contain resources that have, for example, security flags on them that indicate that those may not be served to this particular party that sent us the query. So yes, but that's a regular access control type of engine that you will need whatever search mechanism you use, irrespective of whether that's this search-based URL or GraphQL or whatever search option. You will need an access control engine for all of those.
Okay, there's some questions. Don't understand, for example, is it possible to show only unequal results? I don't know. What does
well, that's kind of interesting. Obviously, we have a parameter modifier that allows you, or rather a comparator that allows you to state that something should be not equal to a particular value. But if the question is, show me, let's say, all things that are not a match related to all of my parameters, then that's quite a different question. But that would, as far as I know, that would require some server-side logic. There is no way we can do that using the standard search URL mechanism.
Another question as well, I don't understand completely. What query would we need to trigger to get everything related to a passion? Meaning passion everything operation only with a certain query.
Even $everything has a predefined definition in terms of scope. For example, if you are following the US core implementation guide, then in US core, it is defined exactly what they mean by $everything, which is effectively the data set known as US CDI, but nothing more than that. So if you want to retrieve really everything, you will have to find a different way of doing so, because $everything doesn't really mean everything. It means whatever you predefine to be the behavior of the $everything operation. It could very well be that on your server or in your country or project, you define $everything to be really everything, okay, with the exception of access control stuff and other resources that are not delivered to you because of that reason. But it's up to the server effectively to define the behavior of $everything. If you use a compartment-based mechanism, like give me everything in a compartment, well, there may be stuff of clinical relevance that's still outside of the patient compartment. So that's still not everything.
Another question is about compartments. So the question is, can we define our own compartments, or we can only use the standard compartments?
Well, that's a very easy answer, because the compartments are, as of today, defined by FHIR and HL7 only. And that's because you want to have, especially for access control, you want to have a standardized way or a standard set of compartments. But obviously you're free, like everything in FHIR, to create an issue and basically suggest that a new compartment be created or that an existing compartment be modified.
As I know, most of FHIR servers implement the custom compartments, at least. I don't know.
Well, most servers also implement custom resources, which is also frowned upon within the FHIR community. But hey, yeah, so I fully understand that. But I'm just responding from the viewpoint of the FHIR specification itself, right? So
another question is about _query search parameter. Do you know any details of implementation? So how it can be done, how it's mapped to the SQL? I don't know. I think it's defined by the server. It's server implementation details, but maybe you have some information about this.
No, I would fully agree with you, and that this is the internals of how you basically deal with a query or a search are entirely up to the server. Yes, if you supply a server with the name of the query, the operation name effectively, and a set of parameters, well, how that server basically creates the result set is entirely beyond the FHIR specification. Obviously, you can discuss best practices around that, but that's an entirely different issue, and we're not going to do that here. That will be something that has a pretty implementation focus, how best to implement search. But no, the FHIR specification is entirely silent on internal behavior on search on servers when processing queries or searches.
Okay. And this is not a question but opinion, that it feels like query syntax could quickly get messier and harder to read than just SQL. So I don't know how. There is no answer for this.
Well, that's certainly true. Obviously, if you, as they did, they started with simple search, and then they added some stuff and added some stuff and added more stuff and added more stuff. And then, yes, it gets pretty hairy pretty quickly. So is this by definition easier than SQL? No, certainly not by definition. But remember, FHIR promises you one thing. We want to cover the simple use cases in a simple fashion. And that's certainly true for this search URL stuff. And that the complex problems require some level of more complexity, that's okay. What we definitely don't want is a complex solution for a simple problem. And that's not what we have when we look at these search URLs, right? So in that sense, it does cover it, but it doesn't cover everything. And that's why the slide I'm still sharing shows you alternative options as well. And I think with that, we're coming up on time, and it's a good wrap up. I will look, by the way, at the questions, and Nikolai probably as well, and we'll try to answer any open questions. So you can look at the question and answer section at a later point in time and see our responses. So thank you, and enjoy the remainder of your Dev Days.
Thank you, Rene. Thank you, everybody. Bye-bye.